Okay. Okay. Good afternoon, everyone. Thank you for being here. My name is Rosa María Vargas Magaña, and I work at the Department of Mathematics. Today, I want to tell you what I do, why it matters, and what keeps me going. I am a water wave modeler. Throughout my academic career, I have been across different environments, from very controlled laboratory-like settings to more isolated and idealized wave phenomena. Over time, my research has evolved, and I moved between theory, numerical modeling, a lot of coding, until in 2023, I joined the SEAS program, and I entered the most challenging environment from the water waves modeling perspective. This is the coastal region, where there are many oceanic processes happening at the same time across different temporal and spatial scales. So I needed to expand my tools and methods of analysis. I introduced field data analysis. I conducted and participate in the design of field campaigns to extract information from waves. Okay. So I needed to collaborate, to expand my network or collaboration, and work closely with other disciplines, with other colleagues from other disciplines. So in short, without exploring this full spectrum of approaches, my understanding of waves will be entirely different, narrower, more biased, just as it once was. So as I said, the coastal region is a highly dynamic system, and there are many fast processes happening and coexisting with the slow motion. So what truly intrigues me are the hidden long period waves that emerge when the group of waves hit the coast. And these long waves travel hidden quietly inside the groups of waves. And they may cause a large impact in the transport of impurities and reshaping beaches, and also can be very destructive in the coastal line. So in summary, my research is focused in this region of the littoral, when the waves start break until they reach the highest point before the water runs back. So when the wave propagates from deep water to the coastal line, the waves start feeling the topography. Waves get taller and slow down. They also align uniformly with the shoreline and producing these wonderful displays of waves. So I am interested in waves that has period between a few seconds up to minutes, because, as you can appreciate in this chart, are the waves that carry the larger amount of energy. So, and this influence the surface water wave levels and the transport of particles. So one example of these waves are swells and infragravity waves. But where these waves come from? Do these waves come from? Well, storms are the major generator or fabric of waves offshore. At the beginning, when this very energetic event happened, there are many waves of different lengths trying to move away from the storm. But given that water waves are dispersive, they travel in groups of waves of very similar frequency, and they interact constructively, and they can be traced from the satellite. And in fact, you can detect the signature of this group of waves for many days after the storm happened. Also, you can obtain information of these long waves from dedicated field campaigns. And you can reveal their behavior and to measure their impact in the transport of particles. Why it's important to study these waves? Where the standard sea state spectra that are usually currently used in the literature fail to capture the generation and propagation of long waves. Also, there are not good estimation of the hydrodynamic forces affecting the offshore structures, and we need better proxies of the coastal wave conditions when these kind of waves approach the shore and may cause a large flooding on the coastal line. And also, we need to develop better models for inertial particles, considering the environmental regimes that matter for the description of the transport of impurities and pollution in the ocean. So if you still have a doubt about the relevance of studying waves, what you can consider now the impact of climate change, and the equation is simple. Stronger storms, more energetic, we have more energetic long waves impacting the coast, and more damage in the coastal line. So the question is, are we truly prepared for this escalating hazard? So you want to keep the discussion going? Please come to see my poster, and thank you for your attention.